Good afternoon, students. In the last class, we discussed the types of vectors, right? So one more type, that is orthogonal vectors, right? So what are orthogonal vectors? In the name itself says orthogonal. That means perpendicular, right? So orthogonal vectors means two vectors which are perpendicular to one another, right? So the angle between the two vectors is 90 degrees. Then those vectors we call as orthogonal vectors. So calling this one as vector A and another one vector B, right? So these two vectors are perpendicular to one another. Vector A, vector B. So angle between them, that is theta, is 90 degrees. So then those vectors we call as orthogonal vectors. So it may be in any direction, right? So vector B, I will write vector C. So vector B and vector C are orthogonal vectors. Vector A and vector B are these two vectors. So ಇದು join ಆಗಿರಲೇಬೇಕು ಅಂತ ಏನಿಲ್ಲ two vectors, right? That means these two are not be co-initial vectors. So if any two vectors which are perpendicular, so one is along y-axis and another one is along x-axis, then those two vectors we call orthogonal vectors. So the vectors between A and B is, that is angle between A and B is 90 degrees. So then A and B are orthogonal vectors. Same wise vector B and vector C are perpendicular to one another. Hence vector B and vector C are orthogonal vectors, right? So if you compare vector A and vector C, so is this vector A and vector C is orthogonal vectors? No, vector A and vector C are parallel, that is anti-parallel vectors, right? So one vector is in the upward direction, so another vector is in the downward direction. That means angle between A and C is 180 degrees. So that's why these two we call as anti-parallel vectors, right? So two vectors which are perpendicular to one another, right? So then those vectors we call as orthogonal vectors. So we can define like this, right? So we can take vector A and vector B as an example. So next, in this orthogonal vector we have orthogonal unit vector. So in the last class we discussed about the unit vector. That means it has unit magnitude, then those vectors we call as unit vector, and the purpose of using the unit vector is to represent the direction, right? So orthogonal means the vectors, that is unit vectors which are perpendicular to one another, then those vectors we call as orthogonal unit vectors, right? So in our coordinate geometry we have three axes, right? So those we call as rectangular components or rectangular coordinates, right? So these three are perpendicular to one another, right? So we known as x, y and z, right? So these are the rectangular coordinate system. So we call this one as rectangular coordinate system. So here what are orthogonal unit vectors? These are the unit vectors. That means x cap, y cap, j cap, a cap, b cap, because these are what the unit vectors, right? So these unit vectors here we are using in the orthogonal. That means the unit vectors which are perpendicular to one another, then those unit vectors we call as orthogonal unit vectors, right? So here in the rectangular coordinate system we have three unit vectors which represents the direction. So this one is very important, right? So those three unit vectors are I cap, right? Next j cap and k cap. So these are the orthogonal unit vectors, right? So here I cap represents what? The unit vector which gives the direction along x-axis. So if we write a vector in terms of I cap, then that vector is along the x-axis, right? So I cap is the unit vector. It gives the direction standard x-axis. So ಎಲ್ಲೆಲ್ಲಿ ನಮಗೆ I cap ಅಂತ ಮೆನ್ಷನ್ ಆಗಿರುತ್ತೆ ವೆಕ್ಟರ್ಸ್ ಅಲ್ಲಿ, so I cap ಯಾವುದು ಡೈರೆಕ್ಷನ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿದೆ ನಮಗೆ? Only the x-axis direction, right? So next J cap, it is also the unit vector. It gives the direction that is along y-axis, right? So similarly, K cap, right? So it is the unit vector which represents the direction along z-axis, right? So these three we call as the unit vectors in the rectangular coordinate system: I cap, J cap, K cap, right? So I cap is the unit vector which gives the direction along the x-axis, J cap gives the direction along the y-axis, and K cap gives the direction along z-axis, right? So you can't say I cap gives the direction along y-axis. So you can't write like this. So here you can't write I cap because I cap gives only the direction along the horizontal component or along the horizontal, right? So this one is the vertical. So for always vertical, we need to write J cap. That being small letters, right? So you can't write in capital letter I, capital letter J, capital K. So these letters must be in small letters, right? So two more important unit vectors. So I cap along x-axis, J cap along y-axis, and K cap along z-axis. So ಇದು next name ಗೊತ್ತಾಗುತ್ತೆ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದ್ದೀವಿ ಅಂತ, right? So these are the orthogonal unit vectors. So if they ask for the orthogonal unit vectors, we need to write I cap, J cap, and K cap in the rectangular coordinate system. ಇಲ್ಲಿ ನೀವು A cap, B cap, C cap ಬರುತ್ತೆ wrong ಆಗುತ್ತೆ because these are the standard values which are given for the coordinate system, right? So x axis, y axis ಮತ್ತೆ z axis. Simply unit vectors means you can write A cap, B cap and C cap, right? So next type of vector, null vector. So in the name itself it says null means nothing is there, right? That means zero vector. We call that one as null vector or zero vector. Right? So that means the vector which having or have which magnitude? Zero magnitude. So any vector which has the magnitude 0, then that vector we call as null vector or zero vector. So null vector is always denoted by 0 to the power vector, right? 0 was bit of melgade arrow mark, right? So this represents the vector, right? So its direct cannot be determined. So ಇದಕ್ಕೆ ಯಾವುದೇ ತರಹದ ಡೈರೆಕ್ಷನ್ ನಾವು represent ಮಾಡೋದು ಬರೋದಿಲ್ಲ, right? So because it is a zero magnitude, right? So it has some values means we can say either along x axis or y axis or z axis, right? So some properties of null vector. So if any vector adds with the zero vector, that means any finite vector is added to a null vector or zero vector, the resultant will be a finite vector, right? So any vector if we add with the zero vector, again we get the same vector, right? So either it may be vector B, vector C or any vector, right? So this one is the first property. And second one is if we multiply the zero vector with a finite vector, so the resultant will be a zero vector, right? So this one is the second property. So if we add any two null vectors, again we get the null vector, right? So this is about the null vector. So important here in all these types of vectors, one is unit vector and another one is orthogonal unit vector, right? So next type, so this will not comes under the type but also studied in types of vectors. So actual vector topic starts from here. So that one is the position vector. So in the name itself says position vector, a vector which gives the position of an object, particle or any matter, then that vector we call as position vector, right? So here somewhere we have one particle here, right? So this particle is represented by a vector, so then this vector we call as the position vector, right? So what is position vector? Position vector is a vector which gives the position of that particle, right? So vector which gives or which represents the position of a particle or object or anything, right? So that gives the definition of a position vector, right? So vector which gives the position of a particle, then that vector we call as a position vector. So right. So here always position vector starts from the origin in the coordinate system. So coordinate system is again x-axis, again y-axis, right? So now ಯಾವುದಾದರೂ ಒಂದು ಪೊಸಿಷನ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಸೊ ಅಲ್ಲಿ ಒಂದು ವೆಕ್ಟರ್ ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ. ಆ ವೆಕ್ಟರ್ ಏನಿರುತ್ತೆ ನಮಗೆ position vector, right? So position vector, the initial point is always starts from the origin, right? So ಈ position ನಾವು represent ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಎಲ್ಲಿಂದ distance ಇಷ್ಟು distance ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಯಾವ ತರ ಹೇಳ್ತಿದೀವಿ, that is from the origin, right? So position vector is always denoted by a letter R. So you need to remember this one. So ನಮಗೆ ಎಲ್ಲೆಲ್ಲಿ R vector R ಇದೆ ಅಂದ್ರೆ it represents what? Position vector, right? So position vector is represented by the letter R. That is, either we can use small letter or in capital letter. So maximum times we are using in the small letter only, right? So capital letter R, we get the another meaning. That means we are representing that R in some other vectors, right? Now, so here we call this vector as vector R. Right now, so this is x-axis, right? So the position of the particle is on the x-axis, somewhere here, right? So now we are going to draw the position vector that should be starts from the origin, right? So this is y-axis, right? So now I draw the vector from O. This point we call as P. So OP is what? The position vector of a particle P, right? So that one we can write either OP, right? So OP is equals to vector R. R vector OP is equals to vector R. That means this vector gives the position of a particle. I am saying the particle is along x-axis. So how we represent that particle along x-axis in vector form? Right? So here we are using the unit vector, right? So unit vector gives what? The direction, right? So vector R is equals to some x. We don't know how much distance it is from the origin, so that one we taken as x. So the direction which represents along the x-axis is what? I cap, right? So ಯಾವುದೋ ಒಂದು ಪಾರ್ಟಿಕಲ್ x-axis ಮೇಲೆ ಇದೆ, right? So this distance ಅಲ್ಲಿ ಇದೆ, we don't know. ಅದನ್ನ ನಾವು ಏನು ತಗೊಂಡಿದೀವಿ? X. So I said R is the position vector. Vector nothing but it has vector ಅಂದ ತಕ್ಷಣ ನಮಗೆ ತಲೆಯಲ್ಲಿ ಏನು ಬರಬೇಕು? One is magnitude. Along with the magnitude, direction, right? So here X gives what? Magnitude. That means if I take in the coordinate system like this, here it is 1, 2, 3. That means x value is how much? 3. So you ordinary geometry ಇದನ್ನ ತಾನೇ ಫಾಲೋ ಮಾಡೋದು. ಯಾವುದೋ ಒಂದು 0, 3 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ x value ಏನಿರುತ್ತೆ ನಮಗೆ 0, right? So here x value is how much? 3. But ನಾನು ಜನರಲ್ ಆಗಿ ತಗೊಂಡಿರೋದ್ರಿಂದ I will take directly as x. So ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ ನಮಗೆ? Along x axis. That's why I represent the direction I cap. Already I mentioned I cap is the direction which is used along the x axis, right? So then we have the magnitude x, and we have the direction I cap. So this gives what? The position vector R. To understand this one, so position vector is denoted by vector R. It has both the magnitude and direction. So if I take along x-axis means I will take generally x, right? So you can take anyone, x0, x1, x2, x3. So ಯಾವುದಾದರೂ ತಗೋಬಹುದು. In case ನಮಗೆ value 3 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ the position vector R is equals to 3 I cap. That means a particle ಎಲ್ಲಿದೆ 3. ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ? x-axis ಮೇಲೆ 3 distance. ಎಲ್ಲಿಂದ? Origin ಇಂದ. Right? Understand this one? So you can take this one as one example. So this is only for along the x-axis. So in the same case, if the position of a particle is along y-axis, so how we will write vector r, that is equals to, we don't know this distance, so in general I will take y, right? So the magnitude is y, right? The distance is, that is direction is j cap, right? So this gives the position of the particle. So iವಾಗ a particle ಎಲ್ಲಿದೆ ನಮಗೆ y axis ಅಲ್ಲಿ ಇದೆ, ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇದೆ ಮತ್ತೆ ಯಾವ axis ಅಲ್ಲಿ ಇದೆ, right? In the same way z axis ಅಲ್ಲಿ ಇತ್ತು. So ಇದು ನಿಮಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, right? x y z, right? So if the particle is on the z axis, right, so somewhere here, so from the origin O, right? So now how we will define the vector r? So I will draw the vector r like this. So here I will draw the vector like this, right? So how we will write vector r is equals to z, we don't know the value z, and the direction is k cap, right? So this vector we have the magnitude and direction, right? So now if any particle is in the plane xy, I will consider here p, right? I will draw the position vector like this, right? So p particle ಎಲ್ಲಿದೆ ನಮಗೆ, from the ordinary geometry we can define this p as, within the brackets how we write x comma y. This is the general form. So if it is 2 comma 3, ಇದೇ ತರನೇ ತಾನೇ ನೀವು ಬರೆಯೋದು in the ordinary geometry, right? So 2 comma 3, this particle is at 2 along x axis and 3 along y axis. Now I am going to represent this vector r here, right? So now I will write the vector r for this case. Vector r is equals to, so it represents x, right? So x I cap plus y j cap, right? So ಇದನ್ನ ಏನಾದ್ರು ಕರಿತೀವಿ in 2 dimension. So in the first case ಅಲ್ಲಿ ನಾವು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದು, these are the 1 dimension. So ಯಾವುದಾದ್ರೂ ಪಾರ್ಟಿಕಲ್ ಓನ್ಲಿ x axis ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಥವಾ ಓನ್ಲಿ y axis ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಥವಾ ಓನ್ಲಿ z axis ಅಲ್ಲಿ ಇರುತ್ತೆ, right? Now so ಇದು 3D ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ, so somewhere ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ, so ಇದು in the space, right? So wall the 3 corners ತಗೊಂಡ್ರೆ, right? So corner ಇದೆ ತಾನೆ wall, so left, right and ground, x y z. So somewhere here one point is there, means so this is the point p. So this is the distance from y axis and this is the distance from x axis. So it is in the space. From here we have some distance, right? So that means it has x comma y comma z. Now how we will represent vector r is equals to x I cap plus y j cap plus z a cap. So this one is the final position vector in 3 dimensions, right? So this is in 3 dimension, or we call this one as in space, this is in plane, and this is one rectangular, rectilinear or simply linear, right? So this chapter is about the plane. So now you come to understand, we are going to position of any object that is along the x-axis and along the y-axis, right? So this is about the position vector. So in any book or any problems, if they mention vector r, that means this is the position vector of a particle, right? So this value is always equals to xi cap plus yj cap plus zk cap. If in the case they given z value is 0, then we have only x plus yj cap. If they given y value 0, we have x and z cap. That means the object is in the plane x and z plane, right? When y is 0. If when z is 0, the object is in xy plane. So understanding this one. So ನಮ್ಮ chapter name is motion in a plane. That means we are considering the two coordinates, either xy or yz or xz, right? So ಇದು general form, ಇದನ್ನು ಗೊತ್ತಿರಬೇಕು, right? So while solving problems, that also we consider. So this is about the position vector. So position vector means it gives the position of an object or a particle, right? So that vector we call as a position vector. That vector is always taken from the origin, right? So ಇದು ಎಲ್ಲೋ axis ಇದೆ, ಎಲ್ಲೋ particle ಇದೆ ಅಂತ ತಕ್ಷಣ ನಾವು ಈ ಪಾಯಿಂಟ್ ಇಂದ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಬರೋದಿಲ್ಲ, right? So position vector is always drawn from the origin. They given 2, 3, that means 2i cap plus 3j cap vector r. They given means it should be from the origin. So origin in the 2 points x axis ಅಲ್ಲಿ ಇದೆ, 3 points y axis ಅಲ್ಲಿ ಇದೆ ಅಂತ ಅರ್ಥ ಆಯ್ತಾ? So this one is the position vector. So very important concept. Exam ಅಲ್ಲಿ what is position vector, types of position vector ಇದು ಯಾವುದನ್ನು ಮೆನ್ಷನ್ ಮಾಡಲ್ಲ. So these are all helpful in while solving the problem and understanding the future concepts. So ಇದು ಬೇಸ್ ಮೇಲೆ next ನಾವು concept shortest distance between the initial vector and final vector, or initial point to the final point. So in that vector we call as displacement vector. In the name itself says displacement, right? So consider 2 points, right? So calling this one as point A and somewhere here point B. So we need to find the displacement between these two vectors, right? So for that, first we need to find where the point A is located and where the point B is located, right? So for that, first we need to draw the position vector for those two vectors. Again, position vector, here is x, here is y. So this one is the origin. So first position vector drawing the vector from the origin to point A, calling this one as R1 or RA, right? So R1 represents what? Position vector of A. Next, draw the vector. So vector and the ನಮಗೆ arrow mark ಇರಲೇಬೇಕು. Without arrow mark, so that represents only the line, that has no meaning, right? So here R2 vector represents what? The position of the particle B. Now we are finding the displacement from A to B, right? So draw the vector from A to B. So this gives vector R from 1 to. Otherwise, if you have any doubt, I will write R A, R B. So here I will write R A B. This is in the suffix. So that means here vector R A B represents what? The displacement between the vector A and vector B, right? So ಇದು next to vector law of addition ಅಲ್ಲಿ ಹೋದಾಗ ಇದೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅಂದ್ರೆ ಯಾವ ತರ ಇದನ್ನ ಬರ್ಕೊಳ್ಬೇಕು ಅನ್ನೋದು ನಿಮಗೆ ಐಡಿಯಾ ಸಿಗುತ್ತೆ. So until now just remember this one. So ಯಾವ್ದಾದ್ರು ಒಂದು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬಿಟ್ವೀನ್ ಎನಿ 2 ಪಾಯಿಂಟ್ಸ್ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಫಸ್ಟ್ ಏನು ನಾವು ಪ್ಲಾಟ್ ಮಾಡ್ಕೋಬೇಕು, ದಟ್ ಈಸ್ ದ position vector. Position vector for a point A and position vector for the point B. Then the resultant is the displacement vector. We need to find the displacement vector from A to B or from B to A, right? So here I am finding the displacement, because displacement is a vector, it has a direction. So from A to B means arrow mark starts from initial point A and ends at B, right? So vector AB gives what? Displacement vector, that is equals to the position vector RB minus position vector RA, right? So displacement vector we always denoted by the letter S. So displacement vector ಅಲ್ಲಿ ತಕ್ಷಣನೇ ನಾವು ಯಾವುದು ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ? Vector S. Vector S represents what? Displacement vector, right? So vector S is equals to RB minus RA. If we consider this one in case of point 1 and point 2, vector S is equals to R2 minus R1, right? So this is in the direction from A to B, right? So I will change this to from B to A, right? So the displacement vector become R1 minus R2, right? So any displacement vector is the difference of the two position vector, right? So ಇಲ್ಲಿ ನಾವು A vector B vector ಅಂತ ಬರ್ಕೊಳಕ್ ಬರಲ್ಲ because we are drawn the position vector. So position vector is always in R, right? So understand this one. This is the displacement vector. So what is displacement vector? So displacement vector is the vector which gives the displacement between the initial point and final point, or the shortest distance between the initial point and final point, right? So that one gives what? The displacement vector, right? So it is iduna so ರಿಮೆಂಬರ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಿ. ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಬಂದಾಗ ಇದು ನಾವು ಏನಕ್ಕೆ ಮೈನಸ್ ಬರ್ಕೊಂಡಿದೀವಿ, R2 minus R1 ಅಂತಾನೆ ಏನಕ್ಕೆ ಬರ್ಕೊಂಡ್ವಿ ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ರೈಟ್? So these are the types of the vectors, right? So the most important is unit vector, next position vector, orthogonal unit vectors, and displacement vector, right? So next, the next topic is vector algebra. So in this we are going to discuss the addition of two vectors. Addition of two vectors. So here we are adding the two vectors. So in this vector algebra we have two methods of adding the two vectors. So in that first method is triangle law of vector addition, right? So the first law is the triangle law of vector addition. So very important for the statement. So they ask for 1 mark for the statement. State triangle law of vector addition. So in board exam. So next one is parallelogram law of vector addition. Right. So these are the two laws of vector addition. So these two are very important. So out of triangle, parallelogram is very important, right? So how we add the two vectors, right? So how to add marking? Vector is nothing but again. So vector and every time you need to remember it has magnitude plus direction. Every time this should be remember magnitude and direction. So taking two vectors, right? So I will take one vector, vector A, plus by taking another vector, vector B, right? So how we add these two vectors, right? So the line segment of this vector A represents what? A represent ಮಾಡ್ತಿದೆ ನಮಗೆ line segment of a vector A represents what? Magnitude. So ಇದು length difference is this vector and this vector, both are vectors but magnitude is differs, right? So the length gives what? The magnitude. So magnitude is plus direction is that, right? So this is along x-axis, we can directly say, right? So one example. So here we have one block. Force, I already say force is a vector. So I am applying 5 Newton force on this block, right? So one force is 5 Newton. Again I am applying another some 2 Newton force on the same block. So again both are in the same direction. We are applying both the forces in the same direction. So illi enagutte namage these two will add up. Directly we can say 7 Newton in this direction, right? So but illi direction and same idana. So one force I am applying along the horizontal and the another force I am applying along this vertical. So ಇವಾಗ ಯಾವ ತರ ಆಡ್ ಮಾಡಬೇಕು ಈ two vectors ನ. So that's why we call that one as the vector algebra. So here we are using the triangle of vector addition, right? So how we add these two vectors means we can take any one vector first, draw parallel to the same vector, right? So I take a vector B which has the same magnitude and same direction. So idu ille baribeku antilla, parallel vector you can write anywhere. So it has the same magnitude and same direction idu andre adana ಏನಂತ ಕರೀತೀವಿ ನಾವು parallel vectors, right? So I taken B, right? So next we call this initial point of a vector we call ಏನಂತ ಕರೀತೀವಿ ಇದಕ್ಕೆ tail end. Tail end of the vector A is added to the head end of the vector B. That means we are joining the tail of the vector B to the head of the vector A to the head of the vector B. So it should be the parallel, right? So parallel means in the same direction and same magnitude, right? We are calling this one as vector A, right? So ಇಲ್ಲಿ two vectors ಇದೆ. So ಇವೆರಡನ್ನ ಆಡ್ ಮಾಡಬೇಕು. ಯಾವ ತರ ಆಡ್ ಮಾಡ್ತಾ ಇದೀವಿ? First I take a vector B. So I as this vector B. Next the tail end of the vector A is joined to the head end of the vector B, right? So if you observe, so this is in this direction. So same here also in the same direction. So ಇಲ್ಲಿ ಮತ್ತೆ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. vector A ಅಂದ ತಕ್ಷಣ either we can write. So again ಆಗುತ್ತೆ. If you call this one vector A, correct ಆಗುತ್ತಾ? So vector A is in this direction. So here it is in the perpendicular direction. So these are not like vectors, right? So now if you observe here, these two vectors represents the two sides of a triangle. I am discussing about the triangle of vector addition, right? So we have two vectors, both vectors have the magnitude and the direction. Then these two vectors represents the two sides of a triangle which are taken in an order. So taken in an order, same order, nothing but if I given the names here A, B and C. So triangle three sides irutte tane, so three corners irutte tane, right? So taken in the same order means from A to B, then from B to C. So that means I am taking in the which direction? Anti-clockwise direction. A in the B ಹೋಗ್ತಾ ಇದೀನಿ, B in the C ಗೆ. That means anti-clockwise. Clockwise ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? From C to B, B to A. So in this direction ಅಂದ್ರೆ clockwise. So I am taking in the anti-clockwise direction. So ಅದನ್ನ ಏನಂತ ಕರೀತೀವಿ? Taken in an order or same order. That is from A to B, then B to C. So triangle ಅಲ್ಲಿ ಎಷ್ಟು sides ಇರುತ್ತೆ ನಮಗೆ? 3 sides. So already we have two sides, right? So these two sides represent the two vectors which represent the two sides of a triangle. Then the third side of a triangle gives what? The resultant of these two vectors, right? So the third side is joining from A to C in the opposite order, right? So this gives what? Resultant R, right? So ivaga triangle ಕಂಪ್ಲೀಟ್, right? So taken in an order ಅಂದ್ರೆ ಏನಾಗಬೇಕು? A ಇಂದ B ಗೆ ಹೋಗಿದೀವಿ, B ಇಂದ C ಗೆ ಹೋಗಿದೀವಿ, again C ಇಂದ ಎಲ್ಲಿಗೆ ಬರಬೇಕಾಗಿತ್ತು ನಾವು? B ಗೆ. This is the order, right? So but ನಾವು ಏನು ತಗೊಂಡಿದೀವಿ? A ಇಂದ C ಗೆ. The direction of the resultant is from A to C. That means opposite to that of the order, right? So the resultant is opposite order. So in the same order ಅಂದ್ರೆ ನಮಗೆ actually ಎಲ್ಲಿಂದ ಬರಬೇಕಾಗಿತ್ತು? C ಇಂದ A ಗೆ ಬರಬೇಕು. Now if you observe the arrow marks from A to B, B to C, C to A. ಇದು ನಮಗೆ ಒಂದು ಕಂಪ್ಲೀಟ್ ಸೈಕಲ್ ಆಗ್ತಿತ್ತು in a particular order, right? So but we take a resultant in the opposite direction. So ಇದು anti clockwise ಇತ್ತು ಅಂದ್ರೆ resultant ಯಾವ ತರ ಇದೆ ನಮಗೆ? Clockwise. So ಅರ್ಥ ಆಯ್ತಾ? So this gives what? The addition of the two vectors. So this resultant gives, it has the direction and magnitude. So observe ಮಾಡಿ ಇದರಲ್ಲಿ line segment length ಎಷ್ಟಿದೆ ನಮಗೆ? ಎಷ್ಟಿದೆ ಸ್ಮಾಲ್ ಇದೆ ಲಾರ್ಜರ್ ಇದೆ compared to these two vectors it has a larger that means addition of two vectors gives what resultant so this resultant we write vector r is equals to vector a plus vector so ಇಲ್ಲಿ first vector b ತಗೊಂಡಿರೋದ್ರಿಂದ vector b plus vector a right so this is what this is the triangle of addition so you can take in any direction if they given in any direction we can add those two vectors the method is same right so ನಿಮಗೆ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಇದು ನಮಗೆ ಒಂದು ಟ್ರಯಾಂಗಲ್ ಇದೆ ಸೊ ಇದು ನಿಮ್ಮದು ನಾರ್ಮಲ್ ಜಿಯೋಮೆಟ್ರಿ ಇದನ್ನ ಯಾವ ಕಡೆಯಿಂದ ಬೇಕಿದ್ರು ತಗೋಬಹುದು ನೀವು a b c c a b and b c a so ಏನ್ ಬೇಕಿದ್ರು ಇದನ್ನ ಕರೆಯಬಹುದು ಬಟ್ ಇನ್ ಟ್ರಯಾಂಗಲ್ ಆಫ್ ವೆಕ್ಟರ್ ಅಡಿಷನ್ ಅಲ್ಲಿ ಆರ್ಡರ್ ಅಂದ್ರೆ it should be starts from a to b then b to c right ಇದು ಟೂ ವೆಕ್ಟರ್ಸ್ ಅವರು ನಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ then resultant should be the opposite ನಮಗೆ c ಇಂದ a ಗೆ ಬರಬೇಕು so that should be from a to c so this gives what the resultant vector if they given two vectors from a to c then from c to b right so calling this one as vector a calling this one as vector b so resultant ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಬರಬೇಕು ನಮಗೆ so this is in the order from a to c c to b so resultant should be from a to b so this gives what the resultant so resultant is always denoted by the capital R right so if we write the statement for the triangle of vectors right so if two vectors represented by magnitude and direction of two sides of a triangle two sides of a two sides of a triangle taken in a same order then resultant gives third side of a triangle magnitude and direction of a third side of a triangle taken in an opposite order. So this gives the statement, right? So two vectors which are represented by the magnitude and direction of a two sides of a triangle taken in a same order, then the resultant gives the magnitude and direction of a third side of a triangle taken in an opposite order, right? Take this example. If they ask for the state and explain, you need to write the statement with this example, right? So taken A, I am adding A with vector B, right? So vector A is added with vector B. So we get first I will write vector A, right? So in the same way, here I am writing vector B. So this gives what vector R in the opposite order, right? So vector R is equals to vector A plus vector B. So this vector is also magnitude and direction. So ಈ resultant ಗೂ ನಮಗೆ ಏನಿದೆ magnitude ಇದೆ ಜೊತೆಗೆ ಡೈರೆಕ್ಷನ್ ಇದೆ. ಸೊ ಅದು ಥರ್ಡ್ ಸೈಡ್ ಆಫ್ ದ ಟ್ರಯಾಂಗಲ್, right? So you can take any example. You can add this one as first example. So here is vector A added with, so name this one as vector B, right? So same wise, first you can draw anyone as first vector A, and this gives what? Vector B, right? So resulting, this one is the vector. It's right line is there. Right, so this is about the triangle of addition. So important for 2 marks. State and explain triangle of addition means you need to write the statement into the example. Anyone example, right? So you need to remember always the tail end of the one vector is added to the head end of the another vector. So you can add any other way, right? So if I take first, I will take vector B, right? So vector B is in this direction, right? So first I take vector B. Now I am adding the tail end of vector A with the vector B, right? So now, so this is vector A, right? So resultant gives the third side of a triangle taken in a reverse order, right? So now observe these two cases. Here I am adding vector R is equals to vector A plus vector B. So here I am adding vector R is equals to vector B plus vector A. So ಎರಡು ಕೇಸಸ್ ಅಲ್ಲಿ ರಿಸಲ್ಟೆಂಟ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ರಿಸಲ್ಟೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಎರಡು ಕೇಸಸ್ ಅಲ್ಲಿ ಏನಿದೆ ನಮಗೆ ಏನಿದೆ ರಿಸಲ್ಟೆಂಟ್ ಎರಡು ಡೈರೆಕ್ಷನ್ ಏನಿದೆ ಎರಡೂನು ಸೇಮ್ ಇದೆ. ಸೊ ಎ ನ ಬಿ ಜೊತೆ ಆಡ್ ಮಾಡಿದ್ರು ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಬರಬೇಕು, ಬಿ ನ ಎ ಜೊತೆ ಆಡ್ ಮಾಡಿದ್ರು ನಮಗೆ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಬರಬೇಕು. ದಟ್ ಮೀನ್ಸ್ ವೆಕ್ಟರ್ A plus vector B is equals to vector B plus vector A. So ಇದು ಯಾವ ಲಾ? A plus B is equal to plus A. Maths. Which law it is? Commutative law. Algebra. A plus B is equals to B plus A. So that gives what? Commutative. That means the vector law of addition is commutative, right? So ನಮಗೆ ಇಲ್ಲಿ ಲೆಂತ್ ಎಷ್ಟಿದೆ, ಇಲ್ಲಿ ಕೂಡ ಲೆಂತ್ ಸೇಮ್ ಬರುತ್ತೆ, ಡೈರೆಕ್ಷನ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ ಇಲ್ಲಿ ಕೂಡ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೇ ಇರುತ್ತೆ ನಮಗೆ. We can add any wise. So ಈ ಕೇಸ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ವೆಕ್ಟರ್ A ತಗೊಂಡು ಆಮೇಲೆ ವೆಕ್ಟರ್ B. So ಇಲ್ಲಿ ಫಸ್ಟ್ ವೆಕ್ಟರ್ B then ವೆಕ್ಟರ್ A. So in each cases arrow are very important, right? So ಇದನ್ನು ಕೂಡ ನೋಟ್ ಮಾಡಬಹುದು. Vector A plus vector B is equals to vector B plus vector A. ಈ ಡಯಾಗ್ರಾಮ್ ಕೂಡ ಡ್ರಾ ಮಾಡಬಹುದು. ಸೊ ಇದನ್ನ ನೀವು ಇಲ್ಲಿ ಪಕ್ಕದಲ್ಲೇ ಬರೆಯಬೇಕಂತೇನಿಲ್ಲ, ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ಬರೀಬಹುದು, ಬಟ್ these vectors should be parallel, right? So ಇದನ್ನ ನೀವು ಕೆಳಗಡೆನೂ ಬರೀಬಹುದು, right? So this is about the triangle of vector addition, very important for 2 marks, right? So in the next class we will discuss parallelogram law of vector addition, right? Thank you. So another doubt